This is section 11.1, and in this section we're going to do our prep work for studying probability. Now, before you can actually study probability, you have to be able to effectively count the ways that something can occur. And sometimes the ways that something can occur, say for example, the lottery, the ways that those numbers can occur is huge. It's huge. So it would be nice to have some help, and that's what we're going to get in section 11.1. We're going to talk first about something called the fundamental counting principle. And here it is specifically for if you have two groups of items. Say you have some shirts and some pants, and you want to know how many different outfits you can get. All right, if you can choose one item from a group of M items and a second item from a group of N items, then the total number of two item choices is M times N. This will make sense when we start looking at our example problems. In general, the fundamental counting principle says the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. All right, let's take a look and see how that concept can be used to help figure out problems. Okay, first one. A restaurant offers 4 appetizers and 9 main courses. In how many ways can a person order a 2-course meal? All right, using the fundamental counting principle, there are 4 possible appetizers, and I'm going to multiply that by, there are 9 possible main courses. That means there are 36 ways. And that's all there is to it. Let's look at number 2. It says a popular brand of pen is available in 11 colors and 2 writing tips. How many different choices of pens do you have with this brand? Okay, there are 11 choices for color. There are 2 choices for writing tips. I multiply those. There are 22 choices. All right. Let's see if it's going to get a little bit more interesting. Here it says a sales representative can take one of 3 different routes from city B to D, and any one of 7 different routes from D to G. How many different routes can she take from B to G going through D? All right. So she's going to go from B to D, and then, let's see, B to D, and then she's going to go from D to G. All right. There are how many ways to get from B to D? There are 3. How many different ways are there to go from D to G? There are 7. That means that there are 21 total ways. Okay, number 4. An ice cream store sells 3 drinks in 3 sizes and 5 flavors. How many different ways can a customer order a drink? Well, 3 drinks, 3 sizes, 5 flavors. All I have to do is multiply those. There are 45 ways. All right, number 5. I'm just using the fundamental counting principle each time. A restaurant offers the following limited lunch menu: main course, vegetables, beverages, and desserts. If one item is selected from each of the four groups, in how many ways can a meal be ordered? For instance, will it be ham, squash, tea, and pie? Or will it be fish, peas, coffee, and sherbet? How many different choices? Well, for the main course, there are 3. For the vegetables, there are 4. For the drinks, beverages, there are 4. And for the desserts, there are 3. If I multiply those, I get 144 combinations. There are 144 different meals that could be ordered. Number 6. A person can order a new car with a choice of 6 possible colors, with or without air conditioning, with or without automatic transmission, with or without power windows, and with or without a CD player. In how many different ways? Well, for color, there are 6 possible colors. Air conditioning, it's with or without. That's 2 choices. Automatic transmission, with or without. That's 2 choices. Power windows, with or without. That's 2 choices. CD player, with or without. If you grab your calculator and you multiply those, and always feel free to pause, do the multiplication, but I get there are 96 orders possible. All right. Number 7. You are taking a multiple choice test that has 5 questions. Each question has 4 answers, with 1 correct per question. If you select one of these choices for each question and leave nothing blank, in how many ways could you answer the questions? All right, question number 1. There are 4 choices. Question number 2. 4 choices. Question number 3, 4 choices. 4 choices, and 5, 4 choices. So I have, you could have said that is 4 to the 5th power. And that will give you 1,024 different possibilities for answers on this 5-question test. All right, number 8. It says, license plates in a particular state display 2 letters followed by 3 numbers. How many different license plates can be manufactured for this state? Okay, letter number 1. There are 26 letters in the alphabet. They did not restrict us and tell us they couldn't pick O. So we have to assume all 26 are valid. Now, the second letter, it did not say there couldn't be a repeat. So, 26. All right. The first number, there's 0 through 9. Those are the only digits possible. And that's actually 10 choices. It did not say you couldn't repeat. So for the second number, there are 10 choices. And for the third number, there are 10 choices. So 26 times 26 times 10 times 10 times 10. How many ways are there to do any one of these? That's what you have to write down. Multiply those, 676,000. And in some states, you'll see that there are 3 letters, and that means there's another 26. So they need a lot of different possibilities. Number 9, how many different arrangements of 6 letters can be formed if the first letter must be W or K and repeats are allowed? All right, there are 6 letters, so maybe 1, 2, 3, 4, 5, 6. The first letter has to be a W or a K. That means there are only 2 choices for that one. Now, for all the others, any letter and repeats are allowed. So it's 26 because there are 26 letters in the alphabet. So it is 2 times 26, 26, and so on. And this is going to be a very large number. This is 23,762,752. Okay? Let's look at our last one. It says a stock can go up, go down, or stay unchanged. How many possibilities are there if you own 9 stocks? Well, for each one of these, for stock number 1, there are 3 choices: up, down, unchanged. For the second one, 3 choices. So what it turns out is that I have 3 times 3 times 3. Whoops. Sorry, I accidentally opened the calculator. Make that go down. 3, 3, 3, 3, 3. I think I have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Once I realized I was doing that, I might have stopped and say that's 3 to the 9th power. Either way you do it, you're going to get 19,683. And that's all there is to the fundamental principle, the fundamental counting principle.